Now, just to give a general sense of what complete square form is, it is changing something that is in the form of ax squared plus bx plus c, like we have down here at the bottom, and changing it into something that looks like this, and that's complete square form. Now, it can be useful to solve equations, but another purpose for it is that when you get these values, this h and this k, you can find the vertex of a quadratic equation, which means the turning point of it. But we'll just go straight into this first example and explain at the end then how you can kind of use the vertex then, just to know a wee bit more context about the equation that you're dealing with. So by converting to complete square form, or they could say vertex form instead, solve x squared plus 8x plus 7. So the first step here is you always take the coefficient of the x, so in this case it's 8, and the first thing you do is you half it, so 8 over 2, and that's going to leave us with 4. The second thing you always do is you take that answer you get from the first step and you square it. So this is the second step, and then the third step, when I square that, I get 16. The third step is you take that 16 and you add and subtract it at the same time into the original quadratic. Now, so what that looks like, that'll look like the x squared that we had plus 8x that we had, and I'll always add and subtract then. And there's a reason why I'll always do the addition and subtraction then, and that's plus 7 as well is equal to 0. Now I'll color code this so it stands out a bit more for you. So that's me adding and subtracting 16. Now I'm allowed to do that because if you add and subtract 16 at the same time, I'm not changing the equation. Okay, this is just a trick that we can do. Now the reason I always add the 16 first and after the x value is because this will always turn into a perfect square. So using the box method for factorizing using a quadratic equation or expression, so that's going to be x plus x, and a little hint here, what goes on the right hand side is always going to be the square root of whatever you added. So in this case the square root of 16 is 4. So it's going to be 4 and 4, and it's going to be plus and plus. And again, I can do a quick check to make sure that's right. When I cross multiply, 4x plus 4x is equal to 8x, and that's what I have here, so I know it's correct because it's the same as the middle term. So I have x plus 4 squared, and then we'll not forget about or minus 16 plus 7. So minus 16 plus 7 is going to be negative 9, and that's equal to 0. Now you've completed the square, or changed it into complete square form there. Now we're being asked to solve this, so we're not done yet, but I'm just going to have a side note here, and the side note is that using these values now, okay, we can find out what the vertex is. So the vertex is, you always take the value that's in the brackets beside the x and you change the sign of it, so it's going to be negative 4, and you always take the value that's outside the bracket, you don't change its sign, you leave it as it is, so minus 4 minus 9. Now that point is the turning point of the original equation that we started off with up here at the top. So that is going to be a U-shaped graph. I know it's going to be some U-shaped graph, and I know now that the turning point at the bottom is minus 4 minus 9, and it's a nice quick and easy way to find the turning point without using calculus. So going back now just to the question, remember we've been asked to solve this, so I'm going to solve for x. So I have x plus 4 to be squared, and that's going to be equal to 9 because I'm going to, add 9 to both sides. I then want to square root both sides to get rid of this squared. and then I'm left with x plus 4 is equal to, this is going to be plus or minus square root of 9, which is 3. And again, I'm going to subtract 4 from both sides, and I'm left with x is equal to minus 4 plus or minus 3. Now, that gives me my two values. X is going to be equal to minus 4 plus 3, which is negative 1, or x is going to be equal to minus 4 minus 3, which is negative 7. And there I have solved a quadratic equation using a complete square form. So we're just going to look at a slightly more complicated question now, and the reason this one is a little bit more complicated is because of that coefficient of the x squared, which is 2. Completing the square or changing into vertex form only works if it's 1x squared, using the method that I did in the first example. So we just have to manipulate this a small bit so we can treat it the same as the first example. And how we do that is we take whatever the coefficient is of the x squared, which in this case is 2, we take it out as a common factor. So I'm going to take 2 out, and that'll leave me with x squared plus 2x plus 5 over 2 is equal to 0. So now you can see I've got a nice 1x squared, and that allows me to jump ahead into the same 3 steps that I did above. So I'm going to take that 2, first thing, and I'm going to divide it by 2, or get a half of it, and that leaves me with 1. Then you always take that value that you get and you square it, and 1 squared is fairly straightforward, it's just 1 again. And then remember, we took that and we added and we subtracted it as the third step. Now you do all this, but just remembering that that 2, I want to leave that outside the brackets. So it's going to be x squared plus 2x. Remember I said I always do the plus 1, and sorry, I'll color code it like I did, plus 1 minus 1 here, so that it'll turn into a perfect square whenever I factorize this trinomial part. So again, I'm going to be left with 2 here, but now to factorize this, or use the bracket method to factorize this mini quadratic that I'm left with here, and I'll always be left with that there, it's going to be x plus 1 all to be squared. So x plus 1 all to be squared. Don't forget again that we have minus 1 plus 5 over 2, so that should leave us with plus 3 over 2, and that's equal to 0. Okay, now I left this general formula up here in the corner for a reason. So y is equal to a times x minus h all to be squared plus k. That a is going to turn out to be 2 now. Okay, so what that means is that I want you to notice is that that a is only being multiplied by this bracket. It isn't being multiplied by this k value. So all that means is that down here I have to multiply the 2 out, the 2 times the 3 over 2. So it's going to be 2 times x plus 1 to be squared plus the 2 times 3 over 2 will leave me with 3, and that's equal to 0. Now again, if you're asked for the turning point of this equation or the vertex of it, you could read that off now as negative 1, 3. So that is the vertex point or the turning point. But this question, we're just going to look at solving this. So now we're going to subtract 3 from both sides. So 2 bracket x plus 1 to be squared will be equal to negative 3. I don't like that 2 in front of the bracket, so I'm going to divide both sides by 2. X plus 1 squared is equal to negative 3 over 2. I don't like the square root, or the square, sorry, so I'm going to square root. So x plus 1 will be equal to plus or minus square root of minus root 3 over 2. Don't forget that plus or minus, because that allows you to get your two values for when you're solving a quadratic. And then x is going to be equal to negative 1 plus or minus root minus 3 over 2. And there's your two answers. If they ask you to decimal points, then use your calculator, or if they ask for it in surd form, then there is your answer.